All right, so number 1 and 2, these are exponential equations because the variable's in the exponent rather than a log. Anytime we have an exponential equation, the domain is all real numbers. On exponential equations, also, our range is that y is greater than our k value. K value is the number added at the end, not in the exponent, but at the end. There is no number added at the end, so we know it's really a 0. So we would say y is greater than 0. On number 2, same thing. There is no number added at the end, so it's a 0. So we would say y is greater than 0. We do a table of values, find a few specific points, some nice points. So we can say 4 times 2 to the power of x. And go to my table. Yeah, so like negative 2, 1 is a nice point. Negative 1, 2. And 0, 4. Those are probably sufficient. So there's this asymptote. It doesn't ask for the asymptote, but it's at y equals 0. So we're going to negative 2, 1, negative 1, 2, and then 0, 4. So let's draw in a curve that hits those points but doesn't cross the asymptote. There we go. Number 2, table of values. Oops. So we've got 4 times 1/2 to the power of x. Let's go to our table. I would say like 0, 4, 1, 2, 2, 1. This has that same k value, so it has a horizontal asymptote of 0 as well. So we go to 0, 4, 1, 2, 2, 1. We're getting closer and closer to the asymptote. Make sure we don't cross it. All right, now, number 3 tells us that interest is compounded. So this is a compound interest problem. So we take our initial amount, 1 plus, then you take your percent, your rate, change it to a decimal. So I have to move the decimal 2 places to the left. So it'll be a 0.08. And then that rate is divided by how many times you're getting interest in a year. It says semi-annually. Semi means half, like semicircle is half a circle. Semi-annual means half a year. So how many times does half a year happen in a year? Well, it happens twice. So we're using an n value of 2. The formula also says to put that n value in the exponent, but then multiply that by the number of years. We're looking at 6 years down the road. So we're going to type this into the calculator. Oops. Let's get out of there. Okay, there we go. 50,000. There we go. So 50,000, 1 plus 0.08 divided by 2, close the parentheses, to the power of 2 times 6, or you can just call it 12. We get $80,051. And we can round to the nearest penny, so that'd be 0.61. Number 4, you deposit $10,000 investment account that earns 7.5% compounds quarterly. So quarterly means n is going to be 4. It is a compound interest problem again. Our initial amount, $10,000. 1 plus your rate. Change it to a decimal, so move the decimal 2 places. 0.075 quarterly, so n value of 4. We're looking for 40 years. All right, so we're going to take $10,000 times 1 plus 0.075 divided by 4 to the power of 4 times 40, or 160. We end up with 195,000 $352.73 if I round that to the nearest penny, 0.7277, so 73 cents. Okay, number 5. The population is decreasing by a constant percent, so that means it's exponential decay. Take our initial amount, that's the 1.5 million. Decay, we would go 1 minus our rate, 6%, as the decimal is 0.06. To the power of, we're going from 2017 to 2035, that's 18 years. So to the 18th power, type that into the calculator. 1,500,000 times 1 minus 0.06 to the power of 18. We get 492,000. And we'll round this to the nearest integer because we're talking about bald eagles. There's not going to be a decimal of an integer. So I'll go 485. 485. Now, we get a calculator back out. Evaluate the following. E to the power, in case you don't remember where E is, on the graphing calculator, it's right here in blue above the ln button. So I have to hit second, ln, to the power of 1/3. You can just hit 1 divided by 3. Inside of that exponent, we'll go to 4 decimal places, so 1.3956. Then ln of 8. So ln 8, 8. 2.0794. Now, log base 8 of 24, 2 ways you can do it. You can use the log base function under your math button, or you can use the change of base formula. If you're using the graphing calculator, I would go hit math, scroll down almost all the way to the bottom. Right here, option A says log base. Choose that. Now we can enter the base we want. So if I want base A of 8 of 24, I get 1.5283. I don't have to round it up because after the 3 comes a 2, which is smaller than 5. Okay, next page. There we go, number 9. 36 and 216 are currently the base numbers. Those are both powers of 6. 36 is 6 squared, so I'm going to write it that way. It's still to the power of 2x plus 4. 216 is 6 to the 3rd, so I'm going to write 216 that way, and it's to the power of x plus 5. So I have power raised to the power. I have to multiply those exponents to distribute. So I have 6 to the 4x plus 8 equals 6 to then multiply these, 3x plus 15. Now you can drop the base numbers since they're the same and just look at the exponents. 4x plus 8 has to equal 3x plus 15. So I'm going to subtract 3x from both sides. I'll also subtract 8 from both sides. So 4x minus 3x is x. Over here, 15 minus 8 is 7. So x equals 7. Number 10. It's an exponential equation. To solve it, I'm going to log both sides. So I'm going to write the word log in front of the left side. I'll write the word log in front of the right side. There's an exponent inside this log, so we move it in front. That's the product, or the power property, rather. So we could write this as log, or x times log of 5 is equal to log of 375. I'm trying to get x by itself. I have to get rid of this log of 5, so I divide by it because it was multiplied. So divide this side by log of 5. In your calculator, you just type in log 375 divided by log of 5. So just use the log button because I don't need a base. So log 375, close the parentheses though, divided by log of 5. So we get that x is about 3.6826. Number 11, there's log base 13s on both sides. I can drop the logs. Then x squared minus 4 has to be equal to 3x. Looks like this is going to be a factoring problem. We need to set it equal to 0. So subtract that 3x over. Put it in order, largest exponent on down to the smallest. So x squared's first, then the minus 3x, and then the minus 4. I'm going to try and factor that. X squared goes to x and x. Two numbers that multiply to negative 4 that also add to negative 3. It has to be a positive 1 and a negative 4. They multiply to negative 4, they add to negative 3. Set each factor equal to 0. So each set of parentheses is set equal to 0. Solve them both. X is equal to negative 1 and x is equal to positive 4. We need to check and make sure these work. Looks like negative 1. When I look at the right side, when I plug negative 1 in there, 3 times negative 1 is negative 3. I can never take log of a negative number. It's not possible. It's undefined, so I get to throw that answer out. It doesn't actually work. When I plug in 4 on the right side, 3 times 4 is 12. That's fine. Plug 4 on the left side. 4 squared is 16, minus 4 is 12. That's fine. So there's no problem with that one. There's my only answer. Number 12, we only have a log on one side, so we can do one of two things. You can exponentiate, or you can rewrite in logarithmic form. They both ultimately give us the same thing. If you rewrite it as an exponential form, you take the base number of 5, you raise it to the power of the other side, 5 to the 5th, and that's then equal to 3 minus x. So now it's not a log at all, but rather an exponent or a algebra equation, a simple algebra equation to solve. I need to simplify that 5 to the 5th. That's 3,125. So that's equal to 3 minus x. So I'm going to subtract 3 from both sides. So 3,122 is equal to negative x. So if I want a positive x, it would equal negative 3,122. Number 13, equivalent expression. So I need to simplify this. So there's a 3 in front of that log. It's going to become an exponent on the 2. So I can write this as log base 5 of 2 to the 3rd. Plus log base 5 of 4. 2 to the 3rd will simplify. 2 to the 3rd is 8. So we've really got log base 5 of 8 plus log base 5 of 4. Here are two logs added together. So if the logs are added together, you take the arguments, the 8 and the 4, and you multiply them. That's the product property. So I have to take 8 times 4. 8 times 4 is 32. So I get log base 5 of 32. I don't need to plug in the calculator and find a decimal. They just want us to simplify it like that. Number 14. Purchased a car 5 years ago, $6,000. If it decreases 11%, that's exponential decay. So you take your initial amount, 6,000, 1 minus your rate, 11%, as a decimal is 0.11. We're looking at 5 years of decay. Plug that in the calculator. 6,000 times 1 minus 0.11 to the power of 5. $3,350. And then if we round that to nearest penny, that's 44 cents. $3,350.44. Number 15. Those are both powers of 4. I can leave the left side alone. 64 I could write as 4 to the 3rd. This simplify that exponent on the right side. So distribute that 3x minus 9. Now I can drop the base numbers and say the exponents equal each other. X plus 35 is equal to 3x minus 9. I'm going to subtract x from both sides. And then I'll also go ahead and add 9 to both sides. 44 is equal to 2x. Divide by 2, so we see that x is 22. Number 16 through 18. Determine exponential growth or decay. Find the exponent. look at the number that is its base number, what it applies to. In this case it's 2. In the second one, that x applies to 1/3. The third one, x applies to 0.5. When that number is larger than 1, it's growth. So number 16, 2 is larger than 1, that's exponential growth. That's all, we're just stating that. 17, 1/3 is not larger than 1, it is less than 1, therefore it's decay. Number 18, 0.5, that's less than 1, therefore that's exponential decay. That's all we have to do on those. Number 19, 20, rewrite in the opposite form. So number 19 is a log, so we have to write it as an exponential. So 4 to the power of 4 is equal to 256. Number 8, we have to go the opposite direction. We have exponential, we have to write it as a log. So the base is 8, so we're going to say log base 8 of 64 is equal to 2. Number 21, evaluate. Log base 5 of 125. We don't need a calculator for this. 5 to some power is 125. It is the power of 3. 5 to the third is 125. Number 22, 3 to some power is 1/27. So ignore for a moment that it's a fraction. Think about 27. We have to raise 3 to a power to get 27. That is the third power. 3 to the third is 27. But the fact that it moved to the denominator means the exponent was negative. So the exponent 3 to something has to be 1/27. It's negative 3. 3 to the negative third is 1/27. Number 23, we're going to solve. The left side of this equation is 2 logs added together. We have to condense them into a single log. Notice they're base of 10s. I don't even need to write the base of 10 if it's a 10. But because they're added, we have to multiply those arguments, 3m minus 5 times m. So distribute that through. We get 3m squared minus 5m. Equals, on the other side, once again, I don't need to write the word log. I don't even need to write the base of 10. It's just, if we don't write a base, it's assumed or understood to be 10. Okay, we have a log on both sides, so we can just drop the logs. 3m squared minus 5m equals 2. We're going to need to set this equal to 0, so I subtract the 2 over. We'll go at the tail end. 3m squared minus 5m minus 2 is equal to 0. So I'm going to have to try and factor this. Unfortunately, it's got a lead coefficient. Makes it the trickier factoring. But consider the numbers that multiply to make 3. That's 1 and 3. Not a lot of options because it's prime. The same thing with the last number, the 2. Numbers that multiply to make 2 are 1 and 2, or 2 and 1. It is negative, so one's positive, one's negative. Let's set up the set of parentheses. 1 and 3, and they both have an m in it, so 1m, 3m. And then I don't know if it's 1 and 2 or 2 and 1. You can try one of them out first, 1 and 2. I know one's positive, one's negative. I'll come back to that. But then if we think about the inside of FOIL, 1 times 3m, that's going to make a 3m. Think about that outside of FOIL, m times 2 is going to make a 2m. We said one would be positive, one would be negative. If one of those is positive and one's negative, is it possible to combine them together to make negative 5? No, it's not. They'd both have to be negative. So that doesn't work. So instead of 1 and 2, let's try switching their order and go 2 and 1. So inside 2 times 3m is a 6m. Outside 1 times m is m. If I make one of those negative, can I get negative 5? Yes, I can. Negative 6 plus 1 is negative 5. So 6 came from the inside, the 2 times 3, so the 2 needed to be negative. The 1 had to be positive. So I now have it factored, m minus 2 and 3m plus 1. So just like we said earlier in an earlier problem, now that it's factored, we have to take each factor. I'm going to do it over here where I have more room. Take each factor and set it equal to 0. So do that with both sets of parentheses. Set them both equal to 0 and solve. So m would equal 2. Here I have to subtract 1. Then I divide by 3. I get negative 1/3. I have to consider if these work. Notice this term right here, log base 10 of m. I get to plug the m directly in. Negative 1/3 doesn't work. Can't take a log of a negative 1/3, so I have to throw that out. What about 2? Consider every log. 3 times 2 is 6, minus 5 is 1. That one would be okay. The next one, and have log base 10 of 2. That one's okay. Far right side's okay. So 2 works, and it's the only one that does work.